Welcome to Database Management System series of video lectures. Today we are going to discuss about Unit 1, Topic 4, that is Data Models in DBMS. What is a data model? Data model represents a visual or graphical representation of data, how the data items are going to be stored, and in what way it is related from one element to the other element. These data models are helps in order to store the data, connect and access and update the data in the database management system. In this data model, we use different kinds of symbols and text to represent the data. So we will be able to show the communication from one data element to the other data element. And what are the set of data items that are available in each and every tabular format. So we have different types of data models available as part of DBMS. The first one is hierarchical data model, network data model, entity relationship model, relational model, object-oriented data model. All these 5 data models are very popular. The first one is hierarchical data model. As the term itself indicates that it is going to represent a hierarchical structure of data elements which are being stored. So in this model, it organizes all the data elements in a tree structure. So it always starts from the root node and then it will have the child nodes and the child node in turn have its own sub-child nodes. So it represents a branch, a group of branches which are connected to the root node. But one important point to be remembered here is in hierarchical data model, every child node will have only one parent node. So this model represents the real world relationships. So here is an example. We have taken a shoe company. Now we wanted to purchase a shoe for the student. If the student is a male, then which type of shoe are suggestible? If the student is female, which type of shoe are suggestible? So shoe is a root node which defines the most generalized element. And shoe element or shoe root node contains 2 child elements. So one child represented by woman's shoe, the second child represented by men's shoe. Again, the men's shoe have been subcategorized into 2 more children. So here, as we move from top node to the bottom node, we will be more specific in terms of its features. And as we go from bottom to top approach, we are going to be more generalized in terms of that particular topic. Right? So this model represents how a generalized data elements that are to be defined should be placed at the root node and how specific the data elements to be are represented to the bottom of the hierarchical data model. All these are the leaf nodes which may not be further subcategorized into the child. The second data model is network data model. From the name, we can understand that a network is nothing but a group of connections. All the elements are interconnected with each other. So the figure also represents in the same manner. So network data model is nothing but an extension of the hierarchical data model which we have discussed just now. And one of the advantage of this network model is that as we move on to a real-time data application, it is not suggestible to go with only one parent element to acquire the properties. So when we want it to be more realistic one, we will be able to acquire the properties from more than one parent, which will satisfy the desired requirements, right? So in this network data model, we will have a child node, which is generated from acquiring the features from more than one parent node. So this is also called as a tree structure with a graph. The example here is we have a store as a root element, which in turn have the child nodes as customer, manager, salesman. Every store or a shop will have these 3 important elements: customer, manager, salesman. Now, customer can place an order, manager can also place an order for retrieving the goods or items from the outside environment. And salesman can also make an or receive an order from the customers. So order is an element which can be defined by accessing the content from customer, manager as well as sales elements. The second child element is item. So items information can be retrieved from the salesman, right? So in this manner, you will be able to relate a single data element with more than one data element. So it is called as a network data model. The third type of data model is entity relationship data model. This is one of the graphical representation of data elements, which gives more insights about the data. So this can also be taken as a high level data model because it visualizes each and every data element in a detailed manner. So whoever look at these data models will have uh, will be able to easily derive a conceptual knowledge about the data element. So let us look at an example of this entity relationship data model. So in this data model, we will use different set of symbols as well as the shapes for representing different data items. Now, we have three different components in this entity relationship model. The first one is entities, second attributes, third is relationship. These are the three important components of entity relationship model. What is an entity? Entity is nothing but a real world thing which represents a real world object. It could be a person, place, or any concepts that you wanted to discuss about. Now here, as part of this example, we have defined two entities named as teacher and department. Now let us go in detail about this entity. An entity is a real world object which defines various information about it. Now, a teacher can have many informations. So each and every information can be taken as an attribute. So what is an attribute? An attribute is also a real world property which defines the entity. Or we can even say that this is the characteristics of the attribute. Now, a teacher is an entity which can be always represented in a rectangular shape. And attributes are always represented in a oval shape. So teacher will have a unique ID number to identify the teacher uniquely. So teacher ID is taken as an attribute. Second information that we can give about the teacher is teacher name. So every teacher will have its own name. The second attribute is teacher name. Third attribute is every teacher will be associated with their mobile number and age and salary. So all these five attributes defines how a teacher is, right? So teacher name, teacher ID, salary, age, mobile number can be taken as attributes. Teacher is referred as an entity. Now, similarly, let us look at the other entity, that is department. Department is a real world entity which will be existing in the real world. Now, this department can also be defined with the help of two more attributes, that is department ID, which represents the every department in a unique manner, and department name. Let us say that computer science is the department name and the department ID can be associated with 733 code as per the Usmania University. Right? Now, these two entities can be related with each other with another symbol, that is rhombus symbol, which is used to represent as a relationship. Now, these two entities are related or associated with each other with a relationship called as works for. So now let us reframe the statement. Teacher entity works for the department entity. So teacher works for their department. There can be multiple number of teachers who all works for single department, right? So we can even represent that mapping cardinalities to represent how many instances of a teacher can be associated with how many entity, how many instances of departments that we will see in the next lecture. Okay. As of now, let us try to understand how is this entity relationship data model can be used. Right. Now moving on to the next one, that is relational data model. In this database context, relation is nothing but a table, right? So putting all the data in a tabular format or putting all the data in a row and column wise manner, representing it as a grid of data. So here a relation model is nothing but a tabular of data which contains all the data elements. So the topmost row can be represented as the features or the characteristics or the attributes of the entity. And each and every subsequent rows can be represented as records. And each and every column is represented as a feature or as well as a tuple. So this is about relational data model. So which gives a detailed information about every entity. So when we have taken employee as an entity here, then EMP ID, employee name, job name, salary, file number, department ID, project ID can be treated as attributes. And the first row, the second row of data items here defines the instance of an entity. So after A001, John engineer with the salary 1 lakh with mobile number and department ID 2, project ID 99 can be taken as an instance of an entity employee. Similarly, you can have a number of instances for the same entity element for the employee entity element, right? So the last type of data model is object-oriented data model, which is a much higher level of representation of data elements. This also gives you a detailed description about what an entity is, what are the data elements that are available as part of it, and what can be the functionalities that can be used with respect to the entity. So object-oriented data model also represents a real world scenario. So here in this data model, we represent both data as well as the relationships which are present within a single structure. So this single element, this single rectangle can be considered as an object. So every object has got its own name, characteristic features represented as attributes, and then functionalities or relationships that are represented as methods. So every entity can have multiple number of objects. Similarly, we have another object called as department. So department is the entity name and attributes are department ID name and the methods. What for a department is used. What can be the actions that can be taken as part of department can be given here. So these two objects can be related with each other, maintaining a relationship. With this, the end of data model.